Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first part of inequalities where I have covered the basics of inequalities and some questions based on it. In case if you haven't gone through that video till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see the concept of inequalities with modular sign, and we'll be also seeing some questions based on it. So let us start with today's video. Suppose if we have an inequality as x less than 2. So this simply means that any values of x which would be lesser than 2 would be satisfying this inequality. But instead of x less than 2, say if we have mod of x less than 2. So that means any values of x for which mod of x would be less than 2 would be satisfying this inequality. Well, before proceeding ahead, first let us try to revise what is a modulus function, which I have already covered in the Maxima and Minima video. So modulus of a function x is defined as x when x is greater than equal to 0, and it is defined as minus x for x less than 0. For example, mod of minus 4 would be plus 4. In a similar way, mod of minus 3.5 will also be plus 3.5. So modulus of a function will always give us a positive quantity. So now if we come back here, we need to find those values of x such that mod of x would be less than 2. Well, to solve this, let us consider two scenarios. The first, let us assume that x is greater than equal to 0. Well, if x is greater than equal to 0, then as per the definition of modulus function, mod of x would be plus x. So mod of x less than 2 can be written as x less than 2. So in this case, when x is greater than equal to 0, all values which are lesser than 2 would be satisfying this mod x less than 2. So from here we can say that x would be lying between 0 and 2, including 0 but excluding 2. In a similar way, if we consider second case, that is when x is less than 0. And we know that when x is less than 0, mod of x would be defined as minus x. So mod x less than 2 can be written as minus x less than 2. So minus x is less than 2, so x would be greater than minus 2. So when x is less than 0, all values which would be greater than minus 2 would be satisfying this inequality. So for this case, the range of values would be minus 2 less than x less than 0. So the range of values of x for which mod of x would be less than 2 would be the union of these and this, which would be between minus 2 and 2. So that means x has to be between minus 2 and 2 such that mod of x would be less than 2. In a similar way, if we consider mod of x to be greater than 2, in that case, the range of values of x for which this inequality holds true would be simply x greater than 2 or x less than minus 2, which can be written as x belongs to minus infinity to minus 2 union 2 to infinity. And here we are using open bracket since we are not considering x equal to 2 or minus 2. So the range of values of x for which mod of x would be greater than 2 would be simply x belongs to minus infinity to minus 2 union 2 to infinity. So if we generalize this, we can say that if mod of x is less than a, in that case, x would be lying between minus a to a. And if mod of x is greater than a, in that case, x would be greater than a or x would be less than minus a. Now, let us consider one more example to understand this in a more clear way. For example, say if we have been given as mod of x plus 3 less than 4, and we need to find range of values of x for which this inequality holds true. So using this definition, we can say that if mod of x plus 3 is less than 4, in that case, x plus 3 would be lying between minus 4 to 4. So if we subtract minus 3 in this inequality, in that case, this would be minus 4 minus 3 less than x less than 4 minus 3, which would be minus 7 less than x less than 1. So x has to lie between minus 7 to 1 such that mod of x plus 3 would be less than 4. In a similar way, if we consider mod of x plus 3 to be greater than 4. In that case, using the same definition, we can write x plus 3 to be greater than 4 or x plus 3 to be less than minus 4. So from here, we can say that x has to be greater than 4 minus 3, that is x has to be greater than 1. And from here, we can say that x has to be less than minus 4 minus 3, that is minus 7. So the range of values of x for which mod of x plus 3 would be greater than 4 would be simply x belongs to minus infinity to minus 7, open bracket, union 1 to infinity. Again, we are using open bracket here since x equal to minus 7 and x equal to 1 does not satisfy this inequality. So we can directly use this to find the range of values of x which would be satisfying given inequalities. Now, let us see some question based on inequalities with modulus sign. So the question here is find the range of values of x that satisfy the given inequality. So we have been given as mod of 3x by 2 plus 5 to be greater than equal to 4. And what is the range of values of x that satisfy this inequality? This inequality can be thought of as mod of x greater than equal to a. And we know that if mod of x is greater than equal to a, then the range of values of x can be found out simply by using x greater than equal to a or x less than equal to minus a. So to find the range of values for this inequality, we can write it to be 3x by 2 plus 5 greater than equal to 4 or 3x by 2 plus 5 less than equal to minus 4. Now we can solve this inequality directly, which would be 3x by 2 greater than equal to 4 minus 5, which would be minus 1. So x would be greater than equal to minus 2 by 3. In a similar way, for this inequality, this would be 3x by 2 less than equal to minus 4 minus 5, which would be minus 9. And x would be less than equal to minus 9 times of 2 by 3, which would be x less than equal to minus 6. So the range of values of x which would be satisfying this inequality would be x greater than equal to minus 2 by 3 or x less than equal to minus 6, which can be written as x belongs to minus infinity to minus 6, including minus 6, union minus 2 by 3 to infinity, including minus 2 by 3. So this is the range of values of x which would be satisfying this inequality. We can also verify this solution simply by taking any random value of x in between this range. For example, between minus infinity to minus 6, we can consider one value of x. Let us assume x to be minus 8. And let us see whether x equal to minus 8 is satisfying this inequality or not. So if x is minus 8, in that case, 3x by 2 plus 5 would be simply 3 times of minus 8 by 2 plus 5, which would be minus 12 plus 5, that is minus 7. And mod of minus 7 would be 7, which is greater than 4. Let us consider one more value of x to be in this range. So between minus 2 by 3 to infinity, let us assume x to be 0 and let us see whether x equal to 0 is satisfying this inequality or not. So if x is equal to 0, in that case, 3x by 2 plus 5 would be simply 5 and mod of 5 would be 5, which is greater than 4. So we can also verify and we can check whether the range of values of x that we have got finally is satisfying the given inequality or not. Now, let us see this question. How many integral values of x will be satisfying this inequality? So we have been given as 5 less than mod of 2x minus 3 less than 17. And we need to find how many integral values of x would be satisfying this inequality. Well, to solve such kind of question, we need to divide it into two parts. The first would be 5 less than mod of 2x minus 3. And the second would be mod of 2x minus 3 less than 17. Now, we know if 5 is less than mod of 2x minus 3, in that case, the range of values of x can be found out simply by using 2x minus 3 to be greater than 5 or 2x minus 3 to be less than minus 5. So using this, 2x would be greater than 8 or x would be greater than 4. In a similar way, from here, 2x would be less than minus 5 plus 3, which would be minus 2. So x would be less than minus 1. So the range of values of x for which this part is satisfied would be simply minus infinity to minus 1 union 4 to infinity. In a similar way, the range of values of x for which this part would be satisfied would be simply minus 17 less than 2x minus 3 less than 17. So if we add plus 3, so in that case, this would be minus 17 plus 3, which would be minus 14 less than 2x less than 17 plus 3, which would be 20. Now, if we divide it by 2, in that case, this would be minus 7 less than x less than 10. So the range of values of x for which this part of the inequality is satisfied is between minus 7 to 10. Now, the range of values of x for which this complete inequality is satisfied has to be the intersection of this range and this range. So if we take the intersection, that is the common range of these and these, in that case, x would be belonging to minus 7 to minus 1 union 4 to 10. So that means the range of values of x would be this, which would be satisfying this complete inequality. So the integral values of x between this range would be minus 6, minus 5, minus 4, minus 3, minus 2. And between 4 and 10, this would be 5, 6, 7, 8, and 9. So altogether, we can see that there are 10 integral values of x for which this inequality holds true. So there would be 10 integral values of x which would be satisfying this inequality. So to solve such kind of questions, we can simply break it into two parts and then we can find the individual range of values of x. And then finally, we can take the intersection of these two range of values of x to get the final range which would be satisfying the complete inequality. So that's it for today's video, in which we have seen the concept of inequalities with modulus sign and some questions based on it. And in the upcoming videos, we'd be seeing quadratic inequalities and inequalities of higher order curves. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again. And still, if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.